All right. So on the left-hand side of that, we've got position time graphs, right? If you were to find displacement, how do you find displacement from a position time graph? You just read them off the graph, right? Just read those 2 points off the graph and subtract, right? Final minus initial. This would be the initial, that would be the final. Just subtract. If you're asked to find average velocity and it's a straight line graph, like so, how do you find average velocity? Simply find the slope. Rise over run. If it's a curved line graph and you need to find average velocity, what do? Find that slope. Okay, it's average velocity. Right? If you're asked for instantaneous velocity and it's a straight line graph, how do you find the slope at an instant? Just find the slope of the line, right? But if it's a curved line graph, how do you find the slope at an instant? You draw the tangent line. Okay? You might want to draw those little pictures on the sheet. That's why I'm doing them up here. Okay? Now on the back side, if you want to just jot at the top of the sheet on the left-hand side, you want to just jot down position time graphs because it doesn't show it there, right? But it still is the continuation of that column, position time graphs. Can you get an average acceleration from a position time graph? No. Can you find instantaneous acceleration? No. Okay, now the right-hand side shows velocity time graphs, which is what you're going to do a little review thingy on today, right? If you're asked to find from a velocity time graph, if you're asked to find displacement, what do? Remember, you find the area. Find the area. If it's above the line, then it's positive. If it's below the line, it's negative, right? If it's, below the axis, that's positive, right? If you've got your graph like this, then where do you find the area? In there, right? And it's negative displacement. Remember doing that? Yeah. Okay. If you're asked to find average velocity, as in step 2, how do you do that? It's simply d over t, where d is calculated like that. You have to find the displacement first. If you're asked for instantaneous velocity, how do you do that? You've got a graph. Just read it right off the graph. It's a graph of velocity. It's easy, right? Graph of velocity is going to give you the instantaneous velocity. Now, if you flip the page over, you can get acceleration from a graph, right? If you're asked for average acceleration and it's straight, how do you find the average acceleration if it's straight? Slope of the line, it's a straight line. Straight line. What if it's curved? When you find average, it's like this, right? It's exactly the same as these ideas here. And if you're asked to find instantaneous acceleration and it's a straight line graph, find the slope between 2 points. And if it's a curved line graph, then it's that whole tangent idea, right? Same ideas. All coming back to you? Slowly. Anybody taking is there advanced math this semester? Is anyone in here taking it? No, no one is? Oh, okay, never mind. Never mind. Okay, so now what I'd like you to do is you've got that second sheet. You'll notice that it is a VT graph. It's a VT graph. There are 9 questions that go with it. Multiple choice. I will start it so you can click in your answer and see how you do. Okay, so the very first one you are to find a bar from 0 to 4 seconds. So average acceleration from a VT graph is the slope. Right? Average acceleration is the slope. So from 0 to 4, that's there to there. So it's obviously going to be negative. So we're at 2 minus 10 all over. Looks like 4 minus 0. Right? So minus 8 over 4 or minus 2. C. Good? Make sense? Taylor, you got to get rid of that earbud. The second one, A bar from 10 to 16. A bar from 10 to 16. Now this is a case here where it's curved, so you do that kind of thing. So it's going to be 0 minus minus 8, so it's actually up 8 and over 6, so that's going to be 1.33, right?
Would it be a lot more than average? Looking at like how often it is.
No, that would be the average. That would be the average. Has to be. I mean, it's flat. It's completely flat here. Right? Okay, number 3, delta D from 0 to 4. So from 0 to 4, I had a couple people ask me, do I just do the triangle? And the answer to that is no. You've got to go all the way from the graph right down to the axis. So it's the triangle plus the rectangle. And the correct answer was?
24.
Was it 24? 24. Nod, yeah, good. Good, good.
This one sucks 5, 2, 5.
Yeah, okay, I'm on 4 though.
No, you're not 4.
I just did 3.
Okay,
Let's do 4. Del 0 to 10 seconds. Now 0 to 10 seconds, so we are talking about triangle, rectangle, rectangle, and then little triangle, and then this guy here. Now, maybe some of you, I'm guessing, probably don't remember how to do it when you've got above and below, right? So here's how to do that, just a reminder. I'll erase it so you can see a little better. So you go 2 and minus 8. So it's 2 minus 8 is minus 6. So the total base is minus 6. The total height is minus 6. From there, that's 7 to 10. That's a distance of 3. So it's minus 6 times 3. And divided by 2 because it's a triangle. And you get minus 9. So this whole thing is minus 9 plus that 24. So which one is the answer? This was 24 here, right?
Why isn't I 10?
It's just the way it works. Yeah. Yeah. So which one was the answer? Was it C?
Yes.
21? 21. 5, 8 inst at 9 seconds. 9 seconds, so right there. So 8 inst, we're talking about the accelerations act. So it's the slope, it's a straight line, so you simply find the slope of the line, right? So that's going to be minus 8 subtract 2, which is minus 10. And we're going from 7 to 10, that's a distance of 3, so minus 3.3. Hey. Right? All coming back to you now?
Yes, I just can't read good.
Okay. Number 6, 8 inst at 14 seconds. So 14 seconds is right there. You're going to have to draw a tangent line. Don't just draw it so that it goes through nice points.
Why not? That's the best technique.
Okay. I would agree these are a little bit too close to each other, but I think the best answer is C.
You didn't even explain anything. You just did the answer.
Well, you find 2 points.
Could you do that?
Find the slope.
Does it have to be on either side?
No. No, just has to be 2 points. Find the
Could it be the
slope.
same point?
No. How are you going to subtract?
I don't know. How does that? Yeah,
Number 7, V inst at 2 seconds. So at 2 seconds, right there, right? So V inst means just read it off the graph, and so C, right? 6. V bar from 0 to 4. V bar from 0 to 4. Now V bar, from a velocity time graph, you have to go displacement over time, right? So we're talking from 0 to 4. So that rectangle plus that triangle, I think it was 24, was it not, the displacement? Divided by time of 4, which is 6 meters per second. The average of all this, 10, 8, 6, 4, 2, I guess it only goes to 4, doesn't it? Only goes to there. So it's 6. The average from 0 to 10. Now 0 to 10 goes all the way from plus 10 all the way down to minus 8. Can you just go 10, minus 8 is 2, divided by 2 is 1. Can you do that? Different shapes, different slopes, everything, right? You have to find that total displacement, which was it 21? You got to find all that displacement, divide by the time, which is 10, and you get 2.1. 2.1. I hope that's all coming back to you. Alrighty, not a lot of time left. I'm sort of jumping around a little bit here. On the very first day, you got this sheet here on velocity, which we went through, right? Right, the one that says 2.3 velocity, little card going around circles. We read that as a group. Okay, we read that as a group, so just a reminder about that. You should now be able to do, or you should now complete the second half of that little method. Okay, it's a little bit more mathematical. You should just sort of go through that, remind yourself of some things. Most of it is all review. Okay, there are a few questions there at the bottom that you should, at the very least, you should at least read them and say, yeah, I know how to do that. Okay, if you're not sure about that question, try it, jot down an answer, check with me. Okay, but at the very least, read the questions and say, yeah, I know all this. Okay, so I'm going to give you the rest of the period to work on that. If you want to work on some problems from yesterday, textbook problems as well, there's going to be a last little bit of class for that as well. We're done with the clickers. Tomorrow you will need your textbook. Tomorrow you will need your textbook. We're going to be looking at graphs a little bit more. Okay, so bring your textbooks tomorrow, sir.